All right, lesson 1 of factoring. You can find this packet that I'll be working with. The link is right on the details of the playlist for factoring. So over here we have a little bit of a warm-up. It's just going to show us that we have to distribute here to simplify. So we're going to have 3 times 2, which is 6. And there's 2 x's there, so that's going to be x squared. And 3x times 5, which is going to be our 15 and 1x. Okay, if we do that on this side, we multiply the coefficients. So negative 2 times 4 is negative 8. And we add exponents. So we have 2 m's here and 3 m's here. So that's going to give us m5. And there's no n to multiply it by, so that n's just going to come down. And then we're going to distribute all the way over to here. So we have negative 2 times negative 7, which is going to give us a positive 14. And m squared, there's nothing to multiply that with, so it just stays the same. And n times n squared is going to be 3n's, and you're done. Okay, so the reason for this warm-up is because what we're going to do to factor out a GCF is pretty much the opposite of what just happened. So remember, factors are numbers or algebraic expressions that are involved in the operation of undistributing. Okay, so therefore, when you're asked to factor something, you are being asked to identify the numbers or algebraic expressions that could have been multiplied together in the first place. So when you're asked to factor a polynomial, you're essentially being asked to undo the distributive property. Okay, so the most basic method, which is the one we're going to start with here, is called factoring out the GCF, otherwise known as the greatest common factor. Oh, I don't know how to spell today. Okay, so let's start with just looking at some integers, some numbers here. So what is the greatest common factor between 14 and 21? Now I'm going to make this really simple for you. This is how I would figure this out. Finding the factors of 14. Well, I always start with 1 and the number itself. So I have 1 and 14. Then I take the number and try to divide it by 2. In this case, I can. 2 times 7 is 14. So then I try to divide it by 3, divide it by 4, divide it by 5, divide it by 6, and the next number is 7, and we've already used that, so we know that we're going to be done factoring this one. Okay, so then I'm going to come over to 21, and again I'm going to start with 1 and the number itself, 21. And then I'm going to see, can I divide 21 by 2? I can't. It doesn't give me an integer. It doesn't work out evenly there. So then I would try 3, and I can do that. 3 times 7 is 21. And then divide it by 4. 21 divided by 5 doesn't work. 21 divided by 6 is not going to give me an integer. And 21 divided by 7 we've already used. So I know that I'm done finding all of the factors. So now, in order to find the greatest common factor, I look at the numbers that I have. 21 is the biggest number, but that's not over here. Then I have 14, but that's not over here. And then I have 7, and 7 is also over here. So therefore, 7 is the greatest common factor between those two numbers. Okay, I'm just going to skip these. You can try them on your own if you'd like to. But I'm going to move on to talk about finding the greatest common factor of monomials when we don't have coefficients, which means that we just have variables. So the GCF of two monomials with the same bases will always consist of the powers with the lowest exponent. Okay, so we have our example here. The greatest common factor, or GCF, of x to the 4th and x to the 7th is x to the 4th. And let me explain that to you. X to the 4th is technically x times x times x times x, right? And x to the 7th is technically x 7 times. So you look and see how many x's do they have in common. Well, there's 4 here, and this guy definitely has 4. So that means we could technically factor out 4 x's from each of these. So x to the 4th is what they have in common, which makes it their greatest common factor. All right, so let's check that out down here. If we have x to the 4th and x to the 3rd, well, x to the 3rd is the lowest exponent, so that means they both can afford to give us 3, so x to the 3rd would be the GCF. Now I'm going to expand this one like I did up here because there's 2 variables this time, so it might get a little bit tricky. So if we have b to the 4th c squared, that means we technically have 1, 2, 3, 4 b's and 2 c's. And then this one has 3 and 3, so we have 1, 2, 3 b's and 1, 2, 3 c's. Right? So now it's easy for us to see what they have in common. There's 1, 2, 3, 4 b's, but there's only 3 over here. So that means the most that we can take out is going to be 3 b's from each of these. So we have b to the 3rd. And how many c's? Well, this one has 3, but this guy only has 2. So that means we can only take out 2 that are in common. So the greatest common factor here is b to the 3rd c squared. Okay, and if we were to do it over here where there's 3 parts, I have xy, I have x to the 5th y squared, x to the 3rd y. Well, now this guy over here only has 1 x and 1 y. So that means that's the most that we can take out of any of them because that's the least that there is. So x1 and y1, if we take that out, that would be our GCF. Because everybody has at least 1 x and at least 1 y to pull out. Okay? So now what happens when we put them together? We're going to find the GCF of the coefficients and we're going to find the GCF of the variable powers, which is exactly what we just did. So finding the GCF of 8x to the 4th and 16x to the 3rd is, well, let's figure this out. If I have 8, I want to find my factors of 8. So I have 1 and 8. Divide 8 by 2 and I get 4. And can't divide it by 3 and then I'm back to 4. So I'm done. 16 and 1 always start with 2 and 8. 16 divided by 3 doesn't give me an integer. 16 divided by 4 is 4. And then I know I'm done because I've already used 4. So what's the greatest common factor between these two numbers? 8. That's the biggest number that they have in common. So we're going to start with 8. And what is the most amount of x's that I can take from both of them? In order to figure that out, I'm going to look for the x with the lower exponent. In this case, it's 3. This means they can both afford to give 3. So x to the 3rd is going to be the greatest common factor. Okay, there's some examples here that you can try on your own. I'm going to jump over to number 5 because it looks a little bit trickier since there's 3 parts. So the first thing I'm going to do is find the factors of -8. Well, I have 1 and 8 and I have 2 and 4. We just did that up there. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. And factors of 12 will be 1 and 12, 2 and 6, 3 and 4. Okay, now if all 3 of these numbers were negative, I would be tempted to take out a negative. But since this number here is not negative, I'm okay just taking out a positive number. Okay, so looking at the numbers, 20, nothing in common, 12, nothing in common, 8, nothing in common, 10, 6, nope, 4. It looks like 4 is going to be the largest number that they have in common. So we're going to take out a 4. And then we're going to see what the smallest exponent is because that's going to be the greatest amount that we can take out. And in this case, it's 2. So 4x squared is going to be the greatest common factor. Okay. I'm going to skip on to the next thing, but I'm going to put that in my next video. So ta-ta for now.